Okay, guys, in this video, we're going to be doing the moment of inertia beam deflection calculation by using Google Sheets. Um, if you don't know how to get a new Google Sheets, basically, if you have your Google account and wherever, like your google.com or whatever, the little waffle at the top right, if you click on that, it'll give you an option to open up a brand new Google Sheets. If you click on Sheets, it'll give you like whatever sheets you guys may have in the past, or if you click the little plus button, that'll give you a blank spreadsheet. Okay, so most likely you will have a blank spreadsheet if you guys are barely starting this for the first time, or if you guys have not worked with Google Sheets before, just click on the little plus sign. Okay, since I had a little bit of time, I went ahead and I actually already started this spreadsheet. I called it moment of inertia and beam deflection. All I did was basically copy down the table that you guys had on the activity. So basically this activity here, I copied down the table kind of like sort of the same way that I have it here. The only thing that I couldn't do was add the pictures. So I basically changed those into, rather than having a picture there, I wrote down vertical or horizontal. Okay, vertical meaning straight up and down, horizontal meaning left to right. Okay, so for this spreadsheet, we're going to try to calculate the area, moment of inertia, depending on, for our values, depending on basically where our numbers are at. Okay, so the first one is in a vertical orientation. Second one is horizontal. The next one is vertical. The next one is horizontal. The next one is vertical. And the last one is horizontal. The numbers are basically the base and the height in inches. So on the left-hand side, you'll see beam A, B, C, D, E, F, and then the base and the height for each one of those beams. Okay. Now, the three things we need to calculate are the area, moment of inertia, and beam deflection. So they all have their own little formula. So make sure that you guys follow the formulas. Okay. If we're using Excel, or in this case, we're using Google Sheets, we're going to write the equal sign. So I'm going to put equals. I want to multiply 1.5 by 5.5. So that'll be basically equivalent to saying C3 multiplied by C4. And that'll give me that, which is 8.25. Obviously, we should know that that is inches to the power of 2, as you can see from the left-hand side. If I take this little dot and then drag it over, it'll do all the rest of the calculations for me. So that'll basically be all of the areas. So once again, Excel is very useful when it comes to performing long and complicated calculations. So now let's do the moment of inertia. The moment of inertia is the formula base times height to the power of 3 divided by 12. So let's do equal sign because we're going to put a formula. Base, the base for this would be, again, C3 times the height, C4. That one's going to be to the power of 3. I'm going to put a little caret symbol and the number 3. And then finally, we're going to be dividing that by 12. So take that and divide it by 12. When I push enter, we got the answer to be 20.79. As you can see, that actually does match our answer. We got 20.80 when we did it by hand. It should be about there, 20.79 when we don't have any rounding errors. So we're going to do the same exact calculation for the rest of the row. And again, Excel does the heavy lifting for us. So basically it does the same exact thing that we have for the first column, or the first column. It'll do the same thing for the other ones. So the next one you should get was 1.54. So this will be a good way for you to check your answers on your handwritten work. That way you know if you did it right or not. Okay. The next one is the deflection in inches. That one is a different formula. So the deflection in inches will be the formula FL to the power of 3 divided by 48 EI, where E is the modulus of elasticity and I is the moment of inertia. So I'm going to put the equal sign for that, meaning we're going to put an equation down. F will be the force. The force is the same thing for all this. That'll be 250 pounds of force. And then we have L, which we said was 144. That was the length of the beam. So times 144. We're going to take that to the power of 3. Now be careful with this because parentheses do matter for this. So I'm going to put a parentheses two parentheses to open it, and I'm going to have this number here, which is the top, or the top of the numerator, basically, of the fraction, and then I'm going to be dividing this by 48 times EI. So I'm going to put another parentheses, 48 multiplied by E, which is the modulus of elasticity. For this problem, we had the modulus of elasticity was 1510000. So 1510000, and then we also have to multiply by the moment of inertia. The moment of inertia happens to be right above this calculation. So the moment of inertia happens to be at C7. So I'm going to multiply that by C7. So it should know exactly where to go. It should know to use that calculation that we just have right above the cell. Okay. So once I push enter, I get that the deflection will be 0.49. And if you notice, that actually matches up with the answer that we had when we did it by hand, right? So 0.4952, we got about the same thing, 0.4952. Now, once again, Excel will be your friend, because once you do repetitive calculations, all you have to do is take the little dot, drag it over to the right side, and it will do the exact same calculation for that whole entire row. So these are actually the moment of inertias that we're going to have by using Google Sheets. Sorry, I keep saying Excel because I'm so used to it. Okay, now, if you notice on your conclusion questions, and this is something that you're going to have to do yourself also, on your conclusion questions, it says that you're going to have to create a graph. And the graph that you want is you're going to have a graph which relates the deflection on the y-axis versus the moment of inertia on the x-axis. So we're going to have a deflection versus moment of inertia graph. And then we're going to have to answer the question, what is the relation between the moment of inertia and beam deflection? Okay, that you can do after you're looking at the graph. So all we're doing here, since we already have the numbers that we need, we're going to highlight the two numbers, the two bottom rows, where we have the moment of inertia and beam deflection, the last two rows. We're going to go to insert. There should be a chart option, right? So chart would be a graph, and it gives you a bunch of different charts or a bunch of different graphs to choose from. So here where it says chart type, we can basically change that to a line, area, column, bar, pie, scatter, whatever you decide to choose. In this situation, I think that the better one would be a scatter plot. Let's see if it did it well. It's not a very good chart. Let's see if the line one works fine. Oop, not really. Bubble chart. I think when I first had this, let's see what this gives us. Not quite. We'll get to the bottom of this. We have to. Let's go back to the scatter one. Let's see. So let's see. X-axis was C7. And that is the moment of inertia. Let's see if that's correct. Moment of inertia should be on the x-axis. Beam deflection should be on the y-axis. So that actually does make sense. I should have stopped this and made two different videos. Okay, I'm going to pause my... All right, so once I go into the scatter chart option, at the very bottom, there's an option that says switch rows and columns. And that is the one that I pressed. Wait, did I do that? So this is what it was before, I believe. And then I clicked on switch rows and columns. And let's see if I can delete some of these dots. It looks like it's all over the place. Yeah, so the y-axis should be going from 0 to 100. That'll be the moment of inertia. And the x-axis should be going from 0 to about 6, something like that. Um, Once you guys have this chart, basically just customize your chart, change the horizontal axis, label it to moment of inertia. There we go, chart and axis titles. I'm like, oh my God, Excel, you're killing me. So deflection versus moment of inertia, that would be the title of our graph. And if you guys want to scoot this over, you can put a couple of spaces on it. And I think you should be able to do that on the title as well. If you change the horizontal axis title, that'll be moment of inertia, which we call capital I. And once you agree that that's what you want, you put it on your chart as well. Oops. Do it. Let's see if it does it for the vertical. The vertical should be deflection. It's doing the vertical one. Let me go back to the horizontal one. This one should be moment of inertia. Okay, so basically there's a chart. It's funky and all because I am not the expert at Google Sheets. It's a little bit different than doing it in Excel. But what you should be able to see from this, it's that as your moment of inertia increases, your deflection should decrease, right? So think about the resistance to deformation. So the moment of inertia is the resistance to deformation. As the resistance to deformation increases, then your deflection should decrease, right? So basically the moment of inertia gets stronger, right? So, or I should say like the material gets stronger depending on the orientation to put it in. And once the material gets stronger in that orientation, then the deflection should decrease. That's what I was trying to get at with this graph. For some reason, it's giving me this funk. So I'm not even going to bother with it. So if you can manage to get this graph right here, I will give you guys full credit. I'm not going to stress about it. It's just a short unit anyways. So hopefully this video is helpful for that. Please turn it in. That way I can give you guys your credit.